Welcome to Zona Mechanica. There is an MCQ on bending of beam. Figure at the margin indicates the weightage of the question, that is 2 marks. Consider a simply supported beam of length 50 h with a rectangular cross section of depth h, width 2h. The beam carries a vertical point load P at its midpoint. The ratio of the maximum shear stress to the maximum bending stress in the beam is. There are 4 options given. Well, let me draw the beam schematically. This is the beam, simply supported beam, and it carries a point load at the midspan, okay, P. So clearly the two reactions will be half of the load P by 2 and P by 2, right? And it's given that length of the beam L is equal to 50 h and cross section, okay, let me draw the cross section of the beam. It is B is equal to 2 into h, and this side D is equal to h. This is at L by 2, okay, and this is L, okay. So the question is, what is the ratio of maximum shear stress tau by maximum bending stress sigma b? Okay, so we have to find out this ratio. So first of all, the maximum shear stress, okay, maximum shear stress will be given by F into A into y bar by I into B, okay, where F is the force, that is P by 2 clearly, and A is the area to be considered for the shear stress. See, this is the neutral axis, okay, neutral axis, and we know since this is a sagging type of bending, so clearly the half portion, the top side half depth will be in compression, while the lower half portion will be in tension, right? And the maximum shear stress will be occurred at the neutral axis, okay, at the mid depth, that is, if this is h total, this will be h by 2, right, h by 2, and this is the area to be considered for the maximum shear stress, right? So A will be is equal to 2h into h by 2, that is h square, right? Now the y bar is the distance of the centroid of this area, from the neutral axis, okay, from the neutral axis, that is this distance, okay. So if we draw here, so this distance, this is the y bar, okay, from the neutral axis, y bar. So clearly it will be half of this height, that is h by 4, right? So h by 4, and I, the moment of inertia, is given by bd cube by 12, since it's a rectangular cross section, okay. So b is 2h into h cube by 12, so h to the power 4 by 6, right? And b is 2h, we know, okay. So tau max will be F is P by 2 and A is H square and Y bar is H by 4 and then 1 upon I is H to the power 4 by 6 and B is 2H. Okay, so clearly it will be, if we solve it, it will come 3 into P by 8H square. Okay, now the bending stress sigma B. So we know sigma B is given by M by I into Y, right? So M is the moment of this force P by 2. See, the maximum bending will occur at the midspan of the beam, right? That is at L by 2. So this force into this distance L by 2 will give the maximum value of the moment. So P by 2 into L by 2. See, L is 50H. Okay, so 50H by 2. This is the moment by I is H to the power 4 by 6 into Y. Y is this H by 2, right? This is the Y. Maximum bending stress will be at the midspan at the neutral axis. Okay, so H by 2, right? So if we solve it, so it will come P by 2 into 50H. See, this is H, and this is H to the power 4. So I'm writing here H to the power 2, okay, into 6, okay, and here this 2 and this 2, here 4 it will be, okay. So if we solve this, it will give 75 P by 2H square, right? So if we go for the ratio, tau max by sigma B, it will be 3P by 8H square into 2H square by 75P. So clearly it will come 3 by 300, that is 0.01. Okay, so clearly it's matching with option D. So option D is the correct answer. Hope you have understood. If you are enjoying, please do share with your friends.